Hi dear students, we start our fourth module, that is AC circuits. You have already learned the passage of a direct current in the circuits and in the conductors, and in dealing with this passage of the direct current, Ohm's law and Kirchhoff's law are sufficient, and the only resistance met in these circuits are the ohmic resistance. You have already learned the passage of DC. DC means direct current in conductors and circuits. Ohm's law and Kirchhoff's law are to explain the passage of DC, direct current in the conductor and circuits. Ohm's law and Kirchhoff's law are sufficient. And the only resistance that met in this DC circuits, that only resistance is the ohmic resistance. Fine. This is the story of DC circuits. ഒരു സർക്യൂട്ടിൽ കൂടി DC ഡയറക്റ്റ് കറണ്ട് പാസ് ചെയ്യുകയാണെങ്കിൽ ആ സർക്യൂട്ടിനെ എക്സ്പ്ലെയിൻ ചെയ്യാൻ, അല്ലെങ്കിൽ ആ സർക്യൂട്ടിൽ കൂടി ഫ്ലോ ചെയ്യുന്ന കറണ്ട്, റെസിസ്റ്റൻസ്, വോൾട്ടേജ്, പവർ, ഇതൊക്കെ മനസ്സിലാക്കാൻ വേണ്ടിയിട്ട്, ഡിറ്റർമൈൻ ചെയ്യാൻ, കാൽക്കുലേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഓംസ് ലോ അല്ലെങ്കിൽ കിർച്ചോഫ്സ് ലോ ഉപയോഗിച്ചാൽ മതി. മാത്രമല്ല ആ സർക്യൂട്ടിൽ ഉണ്ടാകുന്ന റെസിസ്റ്റൻസ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഒമിക് റെസിസ്റ്റൻസ് മാത്രമാണ്. ബട്ട് when we deal with the AC means this is alternating current. Though the electric principles are same, but situations are quite different from that of the DC circuits. Here the alternating current means, you might have studied in the plus 2 classes, that is on x-axis omega t and on y-axis the voltage, and it is a alternately varying voltage. If it is a current, then that is also an alternately varying current. That is, when dealing with the alternating current, though the electric principles are same, the situations are quite different. The current and EMF are changing in value and phase. That is, when we deal with the AC circuit, the currents and EMFs are changing in value and phase. Whereas, when we deal with the DC circuits, the current and EMFs are constant. It is not varying with the time, or that are not changing in value and phase. Therefore, the situation is quite different in the case of AC circuits. And what are the resistance met in the, what are the impedance met in the AC circuits? That is, in addition to the ohmic resistance, resistance due to capacitance, resistance due to inductance come into the picture in the case of the AC circuits. Therefore, Ohm's law and Kirchhoff's law cannot be applied in their original form to AC networks. That is, in the AC network, we use the capacitors, inductance, and also the resistance. Therefore, in addition to the ohmic resistance, resistance due to capacitance and inductance come into the picture. Therefore, Ohm's law and Kirchhoff's law cannot be applied in their original form to AC network. Then, what we will use in the case of the AC network? That is to find out the voltage, current, power, etc. We use some analytical method in solving problems in distribution of AC. Fine. We discuss what are this analytical method that is used to solve the problems in the distribution of AC. That is the next topic. It's a method of solving AC problems. Here we have the three methods. Okay, what are the three methods? Before that, what is the solving an AC problem? Solving an AC problem means to find out the current, voltage, total impedance, and total power in the AC circuit at any instant of time. That is a meaning of the solving an AC problem, finding out this voltage, current, power, and impedance in the AC circuit. Fine. For that, we use three methods, and I will list out the three methods here. The first method, that is by writing down voltage and current equations in a circuit and finding out their solutions. അതായത് ഒന്നാമത്തെ മെത്തേഡ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വോൾട്ടേജ് കറണ്ട് ഇക്വേഷൻ എഴുതാം സർക്യൂട്ടിലെ, എന്നിട്ട് അതിൻ്റെ സൊല്യൂഷൻ കണ്ടുപിടിക്കാം. വോൾട്ടേജ് കറണ്ട് ഇക്വേഷൻ എഴുതുമ്പോൾ അതൊരു ഡിഫറൻഷ്യൽ ഇക്വേഷൻ ആയിരിക്കാം, അതിൻ്റെ സൊല്യൂഷൻ കണ്ടുപിടിക്കാം. The second method, by drawing vector or phasor diagrams and solving this by geometrical methods. Fine. നിങ്ങൾ പഠിച്ചിട്ടുണ്ടാവും എങ്ങനെയാണ് വെക്റ്റർ ഓർ ഫേസർ ഡയഗ്രാം വരയ്ക്കുക, എന്നിട്ട് ജോമെട്രിക്കൽ മെത്തേഡ്സിൽ ഉപയോഗിച്ച് അതിങ്ങനെ സോൾവ് ചെയ്യുക എന്നുള്ള കാര്യങ്ങൾ നിങ്ങൾ പഠിച്ചിട്ടുണ്ടാവും. ഓക്കെ, this is a quite easier method, that is by drawing vector or phasor diagram and solving it by the geometrical methods. And the third one, that is by using J operators. I will explain what's the meaning of J operator later. Here we will follow these three methods, and out of which we will be concentrated in the second and third method. Fine. Now let us go to the simplest case, that is an AC through a resistor, an alternating current through a resistor. That is, we have a circuit consists of a resistor only, and is connected to a alternating voltage source. That voltage source is represented by E is equal to E0 sin omega t. This is the representation of the AC voltage. Because of this voltage, a current I, that is alternating current, that flows through the circuit, and R is the resistance of the circuit. Now here our task is obtain an expression for the current and the relation between the current and voltage in the circuit. That is, we know the equation of the voltage from the Ohm's law. V is equal to I into R. This current is equal to V by R. Here, to find out the expression for the current, IE is equal to, is nothing but total resistance in the circuit is R, it is the voltage divided by the resistance, that is equal to E is given by E0 sin omega t by R. This term is nothing but the current I0. Therefore, here I can write this current I is nothing but I0 sin omega t. This is alternating current that is flowing through this circuit. Now, if I draw the phasor diagram, this is familiar to you because you have already learned in the +2 class. That is, we represent the voltage along the x-axis and current along the y-axis. This VR means the voltage through the resistance R. To write the relation between the voltage, that is applied voltage in the circuit here, E, and the current, we have to check the phase of these voltages, voltage and the current. There is no phase difference. Here omega t, here also omega t. There is no phase difference between the current and the voltage. If there was another term in the current, like if the current was I is equal to I0 into sine omega t plus pi by 2, then we could say the current, there is a phase difference pi by 2 between the current and voltage. But in the present case, there is no phase difference between the current and voltage. Therefore, the phase difference we usually denoted by phi, and phi is the phase difference between the current and voltage. Here there is no phase difference. We can say here the omega t plus 0, this the phi is here is 0. Therefore, there is no phase difference between the current and the voltage in this pure resistor circuit. Therefore, if I write in this picture, if this was angle phi, here the angle phi is equal to 0, which means the current lies exactly on the voltage. This current and voltage both are along the same direction. This current and voltage are in phase. Current and voltage are in phase. Then next we have to draw the graph of this voltage and current. This will be the voltage. This is a voltage E. Then if I write the current, see if this picture in this expression, the magnitude of the current, that is reduced by a factor 1 by R. Therefore, while we plotting the graph of the current, it will be slightly lesser in magnitude. Therefore, this will be the current. Both are in the same phase. Same phase in the sense both value goes to 0, that is the voltage and the current meets 0, the same phase omega t. There is no leading or lagging of the voltage and current. Both the current and voltage are in phase. That is our Phasor diagram is this one. Fine. Now let us go to the second circuit, that is we will analyze the AC through inductance. Here we have a inductor connected to a voltage source, alternating voltage. The applied voltage here is E is equal to E0 sine omega t, and L is the inductance. Because of this applied voltage, an alternating current flows through the circuit, that is represented by I. Since the voltage is an alternating voltage, then a back EMF will be developed across this inductor. That back EMF across L is given by E is equal to L di by dt, and this E is nothing but the applied alternating voltage E0 sine omega t. Therefore, this can be written as E0 sine omega t is equal to L di by dt. Or if I rearrange the term, I can write here di by dt is equal to E0 by L sine omega t. If I do the integration, this will be equal to, I can take this dt to right side, then do the integration. That is, I can be written as integrate E0 by L sine omega t dt. That is, I is equal to E0 by L integration of sine omega t dt. That is nothing but minus cos omega t by omega. There will be integration constant a. Now to find out the value of a, the constant a, we have to put the initial condition. Put t is equal to 0, that is initial condition. That is, when t is equal to 0, there was no voltage source in the circuit or no voltage flows through the inductor. Therefore, E is equal to 0. Is, let me write E0 is equal to 0. And the current will be equal to 0. If you put all these values into this expression, we will get the constant A is equal to 0, because this term is 0, this is 0, then A is equal to 0. Therefore, this current finally I can write I is equal to minus E0 by L cos omega t. Here, I would like to bring your attention on an identity that you have already learned, the sine of theta minus pi by 2. Apply sine A minus B relation, that is sine A cos B minus cos A sine B. Cos pi is equal to 0, cos pi by 2 is equal to 0. Therefore, this will be minus cos theta, because this quantity is equal to 1. That is, if sine omega t minus pi by 2 is equal to minus cos omega t, then if you take this minus with this minus with the cos omega t, this will be E0 by L minus cos omega t. This cos omega t, if you check here, this minus cos omega t can be written as sine omega t minus pi by 2. This will be E0 by L sine omega t minus pi by 2. This is nothing but our current, alternating current I. Why we have converted this cos omega t into this sine omega t minus pi by 2? That is just for the comparison with the applied EMF. The applied EMF is in terms of the sine function. Therefore, to know the value of the current, that should also be in terms of the sine. Therefore, we have changed the cos omega t into this sine omega t. Now, if you connect this voltage and the current, this voltage is E is equal to E0 sine omega t, that is applied voltage, and the resulting current in the circuit, that is E0 by L sine omega t minus pi by 2, or I can write this current I is equal to I0 sine omega t minus pi by 2. That is, if you compare this voltage equation and this current equation, the phase of the current, that is differ by a factor pi by 2. That is, we can say that the current lags behind the applied EMF by an angle pi by 2. That is, I will write here the physical meaning of this minus pi by 2 is this one. Current lags behind the applied EMF by pi by 2. Or I can say it is a voltage leads this current by pi by 2. If I draw the Phasor diagram, current, and this is a voltage across inductance VL, that voltage is nothing but our this E. That voltage leads the current by pi by 2 means the angle between these two, that is phi, is pi by 2. The direction of this angle is this direction, anti-clockwise. Fine. Then if I plot the graph, this is the omega t and this is the voltage or current. If you go back to this equation of the voltage, the sine omega t, the sine omega t has the values 0, pi by 2, 2 pi by 2, that is pi, 3 pi by 2, 4 pi by 2 means that is 2 pi, and 5 pi by 2, then 6 pi by 2 means 3 pi. For all these values, that is for when omega t is equal to 0, the value of E is equal to 0. When omega t is pi by 2, the value of E is E0, and when the value of omega t is pi, then this again 0, 3 pi by 2, this will be minus E0, and it goes on. Accordingly, if you plot in the graph, that is, we have to mark this pi by 2, this pi, this 3 pi by 2, and this 5 pi by 2, sorry, 2 pi, this is 5 pi by 2, and this is 3 pi, etc. Then this is the maximum value of E0. The maximum here goes to when pi sine function goes to 0, and also this is minus E0 value. This value goes down, they again increases, again decreases, goes on like this. Now, what about the current? This current lags behind the applied voltage by pi by 2. അപ്പോൾ ഇവിടെ ആദ്യം പോകുന്നത് വോൾട്ടേജ് ആണ്. ആ വോൾട്ടേജിൻ്റെ ബാക്കിലാണ് നമ്മുടെ കറണ്ട് പോകുന്നത്. മാത്രമല്ല നമ്മുടെ കറണ്ടിൻ്റെ മാഗ്നിറ്റ്യൂഡ് ഇവിടെ ഈ എൽ ബൈ എൽ എന്ന് പറയുന്ന ഫാക്ടർ കൊണ്ട് ഡിവൈഡ് ചെയ്തിരിക്കുന്നത് കൊണ്ട് ഈ എക്സ്പ്രഷനിലെ കറണ്ടിൻ്റെ മാഗ്നിറ്റ്യൂഡ് I0 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ചെറിയ വാല്യൂ ആയിരിക്കും. അതുകൊണ്ട് നമ്മൾ മാഗ്നിറ്റ്യൂഡ് റിപ്രസെൻറ്റ് ചെയ്യുമ്പോൾ ചെറിയ മാഗ്നിറ്റ്യൂഡ് ആയിരിക്കണം. അപ്പോൾ നമ്മുടെ കറണ്ട് നമുക്ക് ഇവിടെ നിന്ന് സ്റ്റാർട്ട് ചെയ്യാം. കറണ്ട് ഇവിടെ 0, pi by 2 ആകുമ്പോൾ 0, ഒരു pi by 2 ഡിഫറൻസ് ഉണ്ടാവും. അതായത് ഒമേഗ ടി pi by 2 ആയപ്പോൾ നമ്മൾ വോൾട്ടേജ് ഇവിടെ മാക്സിമം ആയിട്ടുണ്ടായിരുന്നെങ്കിൽ നമ്മുടെ കറണ്ട് ലാഗ്സ് ബിഹൈൻഡ് ദ വോൾട്ടേജ് ആണ്. അപ്പോൾ അതേ ടൈം ഒമേഗ ടി എന്ന് പറയുന്ന ആ പർട്ടിക്കുലർ ടൈമിൽ, ഈ ഒരു ടൈം ടിയിൽ അതേ പോയിന്റിൽ നമ്മുടെ കറണ്ടിൻ്റെ വാല്യൂ 0 മിനിമത്തിലായിരിക്കും. അതാണ് ഒരു pi by 2 ലാഗ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ. പിന്നെ അതിന് മാഗ്നിറ്റ്യൂഡ് വോൾട്ടേജിൻ്റെ അടുത്തേക്ക് ഉയരാൻ പാടില്ല. കാരണം വോൾട്ടേജ് ഇവിടെ വോൾട്ടേജിൻ്റെ എൽ എന്ന് പറയുന്ന ഫാക്ടർ ഡിവൈഡ് ചെയ്തിരിക്കുന്ന I0 എന്ന് പറയുന്ന മാഗ്നിറ്റ്യൂഡ് E0ൻ്റെ അത്ര വരില്ല, ഒത്തിരി കുറവായിരിക്കും. അതുകൊണ്ട് നമുക്കിതിൻ്റെ മാഗ്നിറ്റ്യൂഡ് ഒത്തിരി ഇവിടെ ചെറുതാക്കിയിട്ട് വരണം. വീണ്ടും 3π/2 എടുക്കുമ്പോൾ ചെറുതാവുന്നു. ഓക്കെ, ഇവിടെ എത്തുമ്പോൾ മാക്സിമം, ഇവിടെ എത്തുമ്പോൾ 5/2 എത്തുമ്പോൾ വീണ്ടും 0 ആവുന്നു. 3π/2 എത്തുമ്പോൾ 0 ആവുന്നു. 3πയിൽ വീണ്ടും അത് മാക്സിമം. അടുത്ത 3π/2 കഴിഞ്ഞാൽ പിന്നെ 3π കഴിഞ്ഞാൽ പിന്നെ 7π/2 വീണ്ടും അത് ചെറുതാവും. Therefore, this is expression for the voltage and this is expression for the current. Sorry, here I did a mistake. That is, I forgot to write this omega in this expression. While copying this expression to here, I forgot to write this omega. That is, here this should be L omega E0 by L omega cos omega t. I am really sorry. Be careful here. Omega is here, omega is here, and here also that omega term is here, L omega. That is, our I0 is nothing but E0 by L omega. Fine. That is, once again I will copy that expression here. I is equal to E0 by L omega sin omega t minus π/2. That is, a current lags behind the voltage by π/2, or the voltage leads the current by an angle π/2. That is, E was E0 sin omega t. Here we have written this E0 by L omega as I0. This I is equal to I0 sin omega t minus π/2. That is, I0 is E0 by L omega. We know that voltage is equal to I into R. I is equal to V by R. That is, the ohmic there is a resistance, total resistance offered by the circuit here, that is L omega. I can write this L omega as the total resistance offered by the circuit, that is XL. XL is nothing but L omega. That is, XL is equal to L omega is the resistance offered by the inductor to the flow of AC. Fine. Here, this XL can also be written as in this form. That is, L omega, you know, omega is nothing but 2πf. This omega is the angular frequency of the AC signal. Therefore, this is a L 2πf. And for a DC current, for a DC, that is direct current. Direct current means if the time t is this is a current or voltage, that there will not be an alternative voltage. This is a direct current or direct voltage. That will be straight one. There will not be any number of cycles per second. For an AC side, this is a particular frequency. This is alternative voltage or alternative current. And for DC, there is no number of cycles per second. Therefore, the frequency F is equal to 0. F is 0 means F is a frequency. Frequency means number of cycles per second is 0 for this DC current or voltage. Okay, we represent voltage as E. Here the frequency is not equal to 0, there is a number of cycles per second is there. Therefore we can write for DC the frequency f is equal to 0. Then if f is equal to 0, our XL, that will be L into 2 pi f, that will be equal to 0. I can write I is equal to E0 divided by XL, that is E0 divided by 0, that is, you can write infinity, that is infinite amount of current flows. That is the resistance offered by the inductor for a DC current is 0. That means if we apply a DC current to the inductor, there will be the resistance offered by the inductor will be 0 and the DC current flows through the circuit. The third circuit that we are going to discuss today is the AC through capacitance. That is, the circuit consists of a capacitor and an alternating EMF source is connected to this capacitor. Capacitance is C. The applied voltage is E is equal to E0 sine omega t. Here also we want to find out what is a current flowing through the circuit. That is, the current is denoted by I. Here we know that the charge stored on the capacitor Q is equal to C into V. V is the potential difference applied, or V is equal to Q by C. Therefore, the charge on the capacitor can be written as Q is equal to C, that is, instead of V we can substitute this E. Therefore we have written Q is equal to C into E, and this E can be replaced by E0 sine omega t. What about the current? If Q is the charge, the current flowing through the circuit at any instant of time can be written as dq by dt, that is equal to C V0 differentiate sine omega t, that is omega cos omega t. Or I can write this as a C E0 omega. Here the applied voltage, that is in terms of the sine, but the current that we obtain in terms of cos. Therefore I can write this cos omega t in terms of the sine omega t as, that is, I am going to replace this cos omega t like sine omega t plus pi by 2. If you write this is sine A cos B plus cos A sine B, this term goes to 0 and this term goes to 1, therefore result is cos omega t. You will get the same step. Fine. Therefore this I is equal to, if I write these three terms, that is in this fashion, E0 by 1 by C omega into sine omega t plus pi by 2. My intention is I can write this term as a E0 by numerator same as it is E0, denominator 1 by C omega. I can write this as a resistance offered by the capacitance, that is XC. For that, that is, this I is equal to E0 by XC into sine omega t plus pi by 2, where xc is equal to 1 by c omega is the resistance offered by the capacitance to the flow of AC. Therefore, we know that this E0 by XC, this is nothing but E0 by R or V by R in Ohm's law. This is I. Therefore, E0 by XC I can write I0. Therefore, this I is equal to I0 sine omega t plus pi by 2. The voltage expression for the voltage, that is E is equal to E0 sine omega t, sine omega t. Then if you compare these two expressions, it is very clear that this is plus pi by 2 is extra, and this shows that the current in an capacitor circuit, pure capacitor circuit, leads the voltage by an angle pi by 2. Plus pi by 2 means leads the voltage by pi by 2. You can note down here, current leads the voltage by pi by 2. By phi is equal to pi by 2. Or I can write in another way, that is, if the current leads means I can write the voltage lags behind the current by an angle pi by 2. Fine. Here also you can draw the Phasor diagram. The voltage lags behind the current means I can write here, instead of you use taking the voltage in the positive y direction, let us take this is in the negative direction. This is the voltage in the capacitance, this is the current, and the voltage lags, it is clockwise direction, this phi is equal to pi by 2. Okay. This is a Phasor diagram of a pure capacitance circuit when an AC current is flowing through it. Here, one more interesting factor that I would like to mention here is the capacitive reactance, that is the resistance offered by the capacitor to the flow of AC, is equal to 1 by c omega. This is equal to 1 by 2 pi fc. Instead, I replaced omega by 2 pi f. And for a DC current, that is a DC current, the better pronunciation is direct current. I already explained, for direct current the frequency f is equal to 0. If f is 0, our xc is equal to 1 by 2 pi into 0 into c, that is 1 by 0. That is, this xc is tends to infinity. Capacitive reactance to infinity means the capacitive reactance, that is the resistance offered by the capacitor to the flow of DC, that is infinity. That is, the capacitor offers infinite amount of resistance to the flow of DC, to the flow of a direct current through the capacitor. That is, simply we can say that the capacitor blocks the flow of DC through the capacitor. This capacitor offers infinite amount of resistance to the flow of DC through it. That is capacitor blocks DC. There is no current flows through the capacitor if a DC is supplied. Fine. Now if we collect all the three phasor diagrams, there is a phasor diagrams of three circuits. The first one is your resistor circuit, that is it contains a resistance and an applied voltage source. The phasor diagram was this one, both the current and the voltage, both the lights along the same direction because the angle was 0. There is no phase difference between the applied voltage E and the current because we had the same expression E0 sin omega t, and the current we have the I0 sin omega t. In the second case, the pure inductance circuit, we had an inductor and the applied AC voltage. The voltage was E0 sin omega t and the current we obtained was I0 sin omega t minus pi by 2. Here we understood that the voltage leads the current. By an angle pi by 2. If you draw the phasor diagram, how we can remember the phasor diagram of these circuits? That is, here if you look at this L, if it is a pure inductor circuit where LE means leads, we always remember that we are leading. We never lags anywhere. We are the leaders. We are born to win. അതായത് നമ്മളെപ്പോഴും ലീഡ് ചെയ്യുന്നതിനെ കുറിച്ച് മാത്രമേ നമ്മൾ ഓർത്ത് വെക്കാവൂ. നമ്മൾ എവിടെയും പരാജയപ്പെടുന്നില്ല. നമ്മളൊക്കെ ലീഡ് ചെയ്യണം, മുന്നോട്ട് പോകണം. അപ്പോൾ ഇവിടെ ഈ ഫേസർ ഡയഗ്രാം 3 സർക്യൂട്ടിനെ വരയ്ക്കണമെങ്കിൽ അത് ഓർത്ത് വെക്കാനുള്ള ഒരേ ഒരു മാർഗം, 3ഉം കൂടി ഓർക്കേണ്ട ആവശ്യമില്ല. റെസിസ്റ്ററിൻ്റെ കേസിൽ നമുക്കറിയാം നോ ഫേസ് ഡിഫറൻസ്. അതായത് ഫേസർ ഡയഗ്രാം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വോൾട്ടേജും കറണ്ടും സെയിം ഡയറക്ഷനിലാണെന്നറിയാം. ഇനി കപ്പാസിറ്ററിൻ്റെ കേസിലാണോ ഇൻഡക്ടറിൻ്റെ കേസിലാണോ വോൾട്ടേജ് ലീഡ് ചെയ്യുന്നത് ലാഗ് ചെയ്യുന്നത് എന്നുള്ള കൺഫ്യൂഷൻ ഒഴിവാക്കാൻ വേണ്ടിയിട്ട് ആണ് നമ്മൾ ഈ ട്രിക്ക് ഇവിടെ മനസ്സിലാക്കി വെക്കുന്നത്. അതായത് എൽ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ലീഡ്, നമ്മളെല്ലായിടത്തും വിജയിക്കുന്നവർ, എവിടെയും നമ്മൾ തോൽക്കുന്നില്ല. ഇപ്പോഴും നമ്മൾ പോസിറ്റീവായിട്ട് ചിന്തിക്കാവും. നമ്മൾ ലീഡ് ചെയ്യുന്ന ആളുകളാണ്. അതുകൊണ്ട് വോൾട്ടേജ് ലീഡ്സ്. ഇഫ് ഇൻഡക്ടർ ഈസ് ദർ, എൽ ഈസ് ദർ, then voltage leads. Voltage leads the current എന്ന് പറയുമ്പോൾ നമ്മൾ എന്ത് വരയ്ക്കണം? ലീഡ് ചെയ്യുന്ന ഫാക്ടർ പോസിറ്റീവ് y ആക്സിസിൽ, കറണ്ട് ഇവിടെ ഈ ആക്സിസിൽ. അതായത് നമ്മുടെ ഫേസർ ഡയഗ്രാം ഇങ്ങനെ ആയിരിക്കണം. ദാറ്റ് ഈസ് phi is equal to pi by 2. ഇനി സർക്യൂട്ട് മൂന്നാമത് നമ്മൾ പഠിച്ചിട്ടുള്ളത് കപ്പാസിറ്റൻസ് സർക്യൂട്ടാണ്. Applied voltage E is equal to E0 sin omega t. Current we obtained is I0 sin omega t plus pi by 2. അപ്പം സ്വാഭാവികമായിട്ട് നമ്മുടെ ഇൻഡക്ടറിൻ്റെ കേസിൽ വോൾട്ടേജ് ലീഡാണെങ്കിൽ, വോൾട്ടേജ് ലീഡ് ചെയ്യുകയാണെങ്കിൽ കപ്പാസിറ്ററിൻ്റെ കേസിൽ വോൾട്ടേജ് ലാഗിങ് ആയിരിക്കും. ഓക്കെ, അതായത് ഹിയർ ഇവിടുത്തെ കൺക്ലൂഷൻ എന്തായാലും നമ്മൾ മനസ്സിലാക്കിയിരുന്നത്, കൺക്ലൂഷൻ ഹിയർ ഈസ് വോൾട്ടേജ്. നമ്മൾ വോൾട്ടേജിൻ്റെ ടേംസിൽ മാത്രം ഓർത്ത് വെച്ചാൽ മതി. ഏത് ലീഡ് ചെയ്യുന്നു ഏത് ലാഗ് ചെയ്യുന്നു എന്നുള്ളത് വോൾട്ടേജിൻ്റെ ടേംസിൽ മാത്രം നമ്മൾ ഓർത്ത് വെച്ചാൽ മതി. voltage lags. Okay. ശ്രദ്ധിക്കേണ്ട പോയിന്റ് ലീഡിനും ലാഗിനും ഒക്കെ എല്ലാം തന്നെയാണ്. പക്ഷേ ലാഗ് ചെയ്യുന്നതിനെ കുറിച്ച് നമ്മൾ ചിന്തിക്കുന്ന പോലുമില്ല. നമ്മളെപ്പോഴും ലീഡ് ചെയ്യുന്നതിനെ കുറിച്ച് മാത്രമാണ് നമ്മൾ ഓർത്ത് വെക്കേണ്ടത്. അപ്പോൾ ഇവിടെ വോൾട്ടേജ് ലീഡ്സ്, സ്വാഭാവികമായിട്ടും ഇവിടെ എന്ത് വരും? കറണ്ട് ലാഗ്സ്. ഓക്കെ. അപ്പോൾ ഇൻഡക്ടറിൻ്റെ കേസിൽ വോൾട്ടേജ് ലീഡിങ് ആണെങ്കിൽ കപ്പാസിറ്ററിൻ്റെ കേസിൽ അതിന് ഓപ്പോസിറ്റ്, വോൾട്ടേജ് ലാഗ്സ്. If voltage lags, then we can write current leads. എല്ലാം കൂടി ഓർത്ത് വെക്കേണ്ട, നമുക്ക് വോൾട്ടേജിൻ്റെ ടേംസിൽ മാത്രം ഓർത്ത് വെച്ചാൽ മതി. Okay, no need to remember which one is lagging or which one is leading. Only thing you have to remember is the voltage. Voltage in the inductor L. L means leads. Therefore, the voltage leads. If the voltage leads, automatically the current lags. But in the case of capacitance, the voltage lags. That no need to remember that one. Okay, if you remember the voltage leads in the case of inductor, automatically the capacitance, in the case of the capacitor, the voltage lags. Fine. If the voltage lags, then of course current leads. Now, if you want to draw the Phasor diagram, that is, what you have to do means, this is a current. Lag, voltage lags means it should be the negative axis. This is the phi. Phi is equal to pi by 2. Okay. In this way, you have to remember the Phasor diagram of the circuit. Then it will be quite easy to solve a circuit contained in the LR, RC and also the LCR circuits. That is our next discussion. Okay. Thank you very much for watching this lecture.